The next speaker is Penousal Machado from the University of Coimbra in Portugal. Penousal has been working on generation of visual art for a long time. He started with evolutionary techniques, if I remember correctly, and he had developed Nevar, which was the very first evolutionary artist that we saw. And he's then moved on and he's started using a lot of these algorithms that Jaime was mentioning. And he now has so many projects, it was very, very difficult to choose one for the demo. And he's going to present one of them that's using ants. Yes.
Hello, good morning. First of all, thanks for the introduction. It's really a pleasure to be here. In fact, I only recently realized that I love lots of the early work that was done here in Madrid. Well, not so recently, 10 years ago or something like that. Well, today I'm going to talk about one of my projects. It's called Photogrowth, and if I have the time, I'll show you a little bit of other projects we have been working on. Let me just try to fix my computer. Yeah, that's better. So I work a lot in evolutionary art. That's one of my main areas of interest, evolutionary computation. And just to give you a little bit of background, evolutionary art really started with the work of Richard Dawkins. And back in 1987, at the first Artificial Life conference, Richard Dawkins presented this software. And it's very easy and very simple piece of software. Basically, it allowed to evolve images of these creatures, these biomorphs, and the way it allowed to evolve this is that you could select on screen the ones that you prefer, and those ones would recombine and mutate and generate a new population and a new population and a new population. So you were a breeder, and actually today, if you go to YouTube and you search for Richard Dawkins, you'll find videos from the 80s and early 90s with Richard Dawkins on television, talking about this program, talking about evolution. And really, if you think about it, it's really, till this date, one of the best demonstrations of evolution in action. And this was the first thing that really kicked in evolutionary art. But then the work that became most influential was the work of Carl Sims. And back in 1991, Carl Sims published this paper called Artificial Evolution for Computer Graphics. He presented the paper at SIGGRAPH, and it had a huge impact. And the reason why it had a huge impact is basically Carl Sims did it all on this paper. He talked about the evolution of these plant-like shapes based on Lindenmayer systems. He talked about the evolution of abstract images like this or this. He even talked and presented videos that were produced by basically by morphing between symbolic expressions and so on. And from there on, the field of evolutionary computation really, and evolutionary art really grew. Lots of researchers and artists like myself got involved in the field, and suddenly you had evolutionary art everywhere. You were doing advertisements for Absolute Vodka. Kevin Kelly was writing about it. It was very popular for a very long time. I won't get much into that because that's a very long presentation. I'll talk about this specific project called Photogrowth. And Photogrowth is based on some of my interests. I like non-photorealistic renderings. I'm not necessarily interested in mimicking natural tools like brushes and paintings and so on, but I like this idea of stylizing an image. I also like ornamentation, and I know this is debatable in the field of art, but I like it. Like you can see by my shirt, I do like ornaments. And I like ants. I don't know why. I try to kill them at my house constantly because I live in the field. They are a big problem, but I do like the animals. They are interesting animals. And the reason why I like ants is because One ant is basically a very dumb animal. They can't do anything by themselves, but together they are very interesting animals as a colony, as a species. And also related with ants, and this is an early example of ant colony art. I also like swarm art, and this is a work by Mauro Annunziato that was also very important at the time of writing. And this is basically the inspiration for this work that I'm going to talk a little bit about. And what I tried to do was put all of these interests together. So basically, what we are going to do is I'm going to use ants to produce non-photorealistic paintings, and then because I have to have a little bit of evolutionary computation in everything, I am going to evolve the species of ants that are going to produce the paintings. And this all started, to be honest, I was in a conference, in a computer science conference, and as we all know, sometimes computer science conferences, they are very boring. So it was so bored, I was so bored that I started coding, just, you know, just to do something. That was how bad it was. We were talking about logic and stuff like that. So this first part was actually all coded in an afternoon. I got this idea that is not original at all of putting ants on top of an image. They would move around, and as they move, they consume ink, they consume light, and they deposit on a different canvas the light they consume. So imagine you have that input image, you put an ant on top of it, the ant has these little sensors, and so it can probe the environment and see where there is light and where is not and move in that direction. Then the ant moves around, and as it moves, it consumes some of the ink, and it's consuming the ink basically by drawing black circles with some transparency, and at the same time that it's moving, it's drawing in another canvas. So I'll show you a quick animation, and is it moving? Oh, it is moving now. Okay, so this is a simulation of the ants. They are moving around, and if energy goes above a given threshold, they reproduce, so they have offspring, and if it goes below a given threshold, well, then they basically die. And eventually they run out of energy, and all the ants are dead, and the simulation ends. So this time, and this is more or less over after 1.5 afternoon, you have basically this. The problem is that now you have literally, I wouldn't say hundreds, but lots and lots of parameters, and if you want to fine-tune the behavior of the ants and make them do something that is really interesting, you'll probably waste a lot of time fiddling with parameters for one thing and the other thing, and so on and so forth. You can, of course, build an evolutionary system like Richard Dawkins did and try to evolve different kinds of paintings and so on. We tried that, we published that. It really doesn't work that well, and the reason why this happens is, well, the simulation takes some time. That's not the biggest problem. The biggest problem is small perturbations, small mutations really make all the ants die, and so you are just evolving based on being able to reproduce the image. You are not being able to evolve something like, okay, now I want an ant species that does, I don't know, spirals or something like that. Then we tried machine learning, and we never published it. And we had some degree of success, but it wouldn't allow us the control that we wanted. And eventually we came up with this idea. And the idea was putting the user back in the loop, but instead of allowing the user to select the images that he or she liked more, instead we would allow the user to design a fitness function. And the way the user designed the fitness functions was using this crazy interface that I'm going to try to explain. Basically, the interface allows you to specify behavioral characteristics of the ants. So, for instance, on the top left corner, you can say, okay, I want that my average number of ants should be around this, more or less. Then you can say, okay, I want the amount of deposit ink, and you can increase or decrease the amount of deposit ink. Or the coverage, you want the ants to cover the entire painting or just a small portion. Or you can say, okay, on average, the distance between the starting point and the end point of each ant should be like this, or smaller, or bigger. You can, and then we got crazy. So you can specify also the average length of the trail, the standard deviations of trails, the average lifespan of the ants, the standard deviation of lifespans of the ants. And then when it gets really interesting is in these two bottom rows where you can specify the average width, but the standard deviation of the average width, or the average standard deviation, which means that you can specify that you want lines that change width constantly and so on, and all these crazy things. You can do pretty much the same thing for the directions. Oh, sorry. You can do pretty much the same things for the directions. So, for instance, if you want, it's pretty easy to say, by using the interface, I want species that do spirals, or that are doing a spiral but then change directions, and so on and so on. And on the bottom row that you probably cannot see due to the piano, you can control some things about that are not behavioral parameters, they are characteristics of the painting. So the similarity with the original input image, the complexity of the drawing that is being produced, and also fractal dimension and linearity, which, by the way, don't work at all. They don't mean a thing. So actually, we never use those icons, but they are there anyway. So the next step was giving this to a design student, and the design student tried to come up with different fitness functions. In fact, he came up with 5 fitness functions, and described these fitness functions for us, and then we run the evolutionary algorithm. And in each run, we are creating thousands of images, and the ones that I'm showing are the fittest ones of those. And you can see the original image and some other images. And for instance, the second one, you can see lots of straight lines. The one on the right, you can see some circular lines. The one on the top right bottom is just the closest possible to the original image, and stuff like that. And once he checked the results, we give it back to him, and he decided to design another 5 more. I actually like a lot the one on the bottom left corner. It's very abstract. The way it was done was this. He was trying to increase similarity with the original, but keeping the image as simple as possible. And the weight given to keeping the image simple was much higher. So you get this sketchy image just with a few lines, because you cannot draw lots of lines, otherwise you increase the complexity. And I think that was very successful. And we give it for 5 more, and we start getting these crazy abstract shapes and so on. So in the end, we got all of these images, all of these runs, and thousands more. But the important thing here is really this. The important thing are not the images. The important thing is that we got different ant species. And these ant species live in this environment, which is the image, and they have these characteristics. So the idea was, now that we evolve an ant species for this image, nothing prevents me from taking this ant species and putting it on another image. And hopefully, all this style will translate to other images. And that's basically what we did. And here we got lucky. Okay, it was just a theory that they would survive in another environment and keep their behavior, so they would be robust. And it turns out that in most cases, there are a few exceptions, but in most cases, they are robust. They present the same characteristics. So now we have a way of evolving ant species that produce a certain type of effect, and we can use that in any image. We did other things that are more related with computer graphics. So during the simulation, to remove and to paint, we are drawing ellipses, small ones, transparent ones, and so on. And this is a little bit nasty when you want to print or when you want to edit the image. So basically then we can convert all these trails of ellipses in lines, in continuous lines of varying width and so on, and transparency also. And these lines can intersect themselves, which is a very cool trick. And actually you cannot do it in almost any software tool. So we can do this online, and once we have lines, we can control lots of aspects of the rendering. Let me try to show you that in simulation. So first, we are just drawing the image, and I believe there is a zoom in. So one end species, and let's see if this happens. So zooming in, you'll see, hopefully, not sure if you can see it with the lights, but you can see the individual ellipses, maybe. And then we convert it to different lines, okay? So now they are lines. They are no longer individual ellipses. And now that you have lines, you can control transparency, you can control stroke, you can control all of these things. Not really necessary, so you can do this stuff. And this gives an additional degree of control to the user, just to change the image a little bit more, to make it its own image, which I believe it's very important to get a sense of ownership. So we can do all these crazy things. And of course, if you use different end species, you'll get different images. So it's just one rendering, totally different end species, totally different feeling, and so on. Of course, we created lots. Actually, this one is one of my favorite end species. We created lots and lots of images. Let me show you just a few, because I know I'm almost running out of time. This one was actually did here in Spain, and this one also. And the cool thing is that now you can try it if you want. We'll have a demonstration out there, and you can try it on my computer, but then if you want, you can also try it at home. We basically created a bot for Instagram, which actually violates the user agreement, but they only blocked us once. And now the bot actually pretends to be a human being, so it sleeps, and so if it does all these tricks. And all you need to do, if you have an Instagram account, you need to follow the bot first, otherwise it won't have access to your paintings, and then to your photos actually. And then you take a photo, you include the hashtag insta.ants, and after a few hours, because the bot is a human person, so it cannot be straight away. After a few hours, it will produce a rendering of you, and it will post it with the hashtag so you can see it. And every now and then, we also create videos. So I believe I still have a few time. So I want to show you very briefly the other types of things that we are doing at my lab. So what else are we doing? At this stage, we have people from computer science doing AI. We have lots of designers, actually, and new media artists, and even some biologists. So we do stuff like this, data-driven book covers, where the cover of the book is actually an information visualization of the content of the book. So if we change a word in the book, it will also change the cover. Or like this, is also the same concept, but here we are mapping the structure of the book to the cover automatically, and we can do it for collections. We have designers, so we do lots of work in typography. For instance, here we are evolving, let me see if this is a video. Here we are evolving typefaces. So the idea is that you can put some objects like your keys, a pen, or something else, take a photo, and then it will evolve a typeface using those objects. So you'll get something like, maybe something like this, that is recognizable but uses your own objects. We do, again, we have designers, so we do lots of typography, lots of posters. In this case, these are typographic posters. They are created by an evolutionary algorithm that is optimizing space. And it's fun because the interesting part of this is the sentences that are written in the posters come from protests, student protests in Portugal and I believe in France. We also do typographic portraits, so recreating faces of humans just by typography, which involves lots of computer vision, actually. We do lots of visual analytics for big companies. And sometimes it's very analytical and very purpose-oriented. In other cases, we are just having fun and trying to do stuff that is influential. For instance, this, I'm very proud of this, and now I'm including this in all presentations. And sometimes I need an excuse, and the reason why I'm proud, this is basically showing the relation between Portuguese politicians and some commercial groups, some banks, some stuff like that. And the reason why I'm proud is because we actually got censored in a newspaper, and it's called Público, in case you want to know, because it was supposed to be the cover story, but at last minute, after the cover was already done, it disappeared. So this is fun, and actually at some point it had something like 10,000 views per day, which was interesting. We also do stuff that is more serious, so this is a visualization for HIV, and sometimes we simply have fun. This is actually very important data about consumption, but rendered in a more creative way, and this is work that we do in data aesthetics. If you go for the Computational Creativity Conference, you'll know that we are creating emojis with conceptual blending, but we also are creating creepy faces with machine learning. And this is actually a face that we all recognize as a face, but that the computer does not recognize as a face. And by the way, the reason why it's creepy is not the piercing. That actually doesn't bother us so much, is the eyes. The eyes are from an old man, and that's what makes the image disturbing. If you change it to the eyes of a baby, it's not creepy at all. We do data-driven posters like this, or reactive posters like this. We do crazy stuff with typography, and one of our latest crazy projects was this furniture that produces sound. So in that case, you have a cabinet, and inside each of the drawers, there's a sound that you can listen. And we are doing other sound-based objects. And that's all for today. Thank you very much.